Hello, this is Mr. Laiche, Portland Math Tutor, and today we are going to work on the SAT Official Practice Test version 1 for 2019. This section of the test is the No Calculator section. These are the useful formulas for area, volume, and some information here about measurements for a circle. We have degrees. 360 is the total number of degrees in a circle. If we're measuring in radians, the total of a circle is 2 pi, and the measures of all the angles in a triangle is going to be 180 degrees. So I think really, if you're not familiar with radians, it's not super important, but there is very likely going to be 1 or 2 questions that require that. I would anticipate at least 2 or 3 questions that require you to know that there's 180 degrees in a triangle. But anyways, so let's continue. The first problem here, we've got let's see, get a pen here. Is x minus 1 over 3 equals k, and k equals 3. So what's the value of x? Okay, so this is just going to be a substitution type problem here. We got x minus 1 over 3 equals k. Well, k equals 3, so we're just going to substitute 3. All right. We multiply both sides by 3, and we'll get x minus 1 equals 9. And then, of course, we're going to add 1 to both sides, so x equals 10. So for this problem, we're working with I. Now, I equals the square root of -1, but that is not really very significant for this particular problem, because really all we're doing is adding 2 expressions, okay? We can just treat I as if it were a variable, such as x. We're just combining like terms. So if we're adding 7 and, let's get a new pen, 7 and -8, well, we're going to have -1. If we're adding 3i and 9i, we're going to have 12i. So that's pretty straightforward. Our answer is going to be -1 plus 12i. Okay, for this problem, on Sunday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? Okay, so get a pen. Okay. All right, so the number of text messages is just going to be the number that Armand sent plus the number that Tyrone sent. So if Armand sent M messages for 5 hours, then he sent M times 5, or 5M messages. If Tyrone sent P messages each hour for 4 hours, he sent 4P messages. So we're going to have 5M plus 4P will be our answer. Okay, number 4. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be represented or estimated with the equation P equals 100 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value of 100 in the equation? Well, we should recognize right away that this is a linear equation. I'm just going to rewrite it in linear or in slope-intercept form. Okay, so we can see that 108 is the y-intercept of the function. And if we know that the function is outputting p, which is the number of phones left, and the input is d, number of days she's been working, and we have a negative slope, we can see that what this is saying is that after 0 days, she has 108 phones left. Okay, so let's go down through our possible answers here. First one, Kathy will complete repairs within 108 days. No, this is saying that she has 108 phones on day 0. Okay, Kathy starts each week with 108 phones to fix. That is exactly what we're looking for. Let's read through the rest. Kathy repairs phones at a rate of 100 per hour. No, she repairs phones at the rate of 23 per day. And then finally, the last one, Kathy repairs phones at a rate of 108 per day. No, that's also not going to be it. Okay, so for this problem, we need to figure out which of the following is equivalent to the expression above. Well, we just have x squared y minus 3y squared plus 5xy squared. Then we're going to distribute this negative onto each of the following terms. So we're going to have this, and this. So what are we going to be left with? Let's see. We're going to have a negative times a negative, so it's going to be a positive x squared y. Then we're going to have a negative times a positive, that's going to be a negative 3xy squared. And then a negative times a negative, and we're going to have a positive 3y squared. Okay, so now we're combining like terms. We've got x squared y here, x squared y here, so we're going to have 2x squared y. Okay, so we can eliminate a couple of these. These top two are not, those two are not going to happen. Then we can look at our y squared terms. So we see that this and this are going to cancel out. So we can see that our answer is going to have to be C. But let's go ahead and continue. All right, so we're going to look at our next term here. We've got xy squared, that's 5xy squared, and negative 3xy squared. That's going to add up to plus 2xy squared. And yes, that confirms our solution. Okay, for the next problem. A pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age, a, in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? Okay, so well, our equation h equals 3a plus 28.6 should really stand out right away as y equals mx plus b. Okay. We know this is a linear equation. It's going to be something of the form, yeah. And we know that the rate of change per year which is based on this input of a in years, is going to be 3. The slope is 3. That means the average rate of change, or the rate of change for this linear function, is 3. That means that the inches growth per year is 3. For our next problem, we have kind of a nasty equation. It says the formula above gives a monthly payment M needed to pay off a loan of P dollars at a R% annual interest over N months. Which of the following gives P in terms of M, R, and N? Really, all we need to know here is that we have P in terms of M, R, and N. That just means essentially solve for P. Okay. Now we've got this kind of a nasty fraction times P, but we can think of it in a simpler way. We can just think of it as M equals something over something times P. Right? Now, if we want to isolate the P, if we want to solve for P, we would have to divide by A over B. Well, dividing by a fraction is the same as multiplying by the reciprocal, or we're just going to multiply by the multiplicative inverse. Okay, we want to cancel out that A over B, so we need to multiply by B over A. Yeah? B over A. Okay? Over on the right side, the B's will cancel out, the A's will cancel out, and we'll just have B. P, sorry. On the left side, we'll have M, but we're going to have B over A. Okay? Well, B over A, if we look back at our equation, in our example here, I just said A over B. Yeah? So what was A in our equation? Well, A was this guy up here, and B was this guy down here. So if we're multiplying by B over A, we're going to look for the denominator in red to be in the numerator in our solution. So it looks like our only solution is going to be right here. Yeah. And then we can look at our numerator, and we see that, yes, the numerator is in the denominator. For our next problem, we have if A over B equals 2, what is the value of 4B over A? Okay. We've got A over B equals 2, and we're trying to figure out what 4B over A equals. Well, I see that we're dealing with A and B in both of them, so why don't we pull that 4 out front? So this is the same as 4 times B over A. Well, B over A is clearly, it's just the reciprocal of A over B. So if we look at our original equation, this guy, if we take the reciprocal of both sides, we'll see that B over A is 1/2. Okay, come down to the bottom, we have 4 times 1/2. That's just 2. Okay. Alright. Okay, all we have here is a system of equations, and it says that we need to solve for x and y, but I'm looking at the solutions and I see that y has some duplicate values, while x doesn't have any duplicate values. So I'm thinking that, gee, if I solve for x, I can just pick my answer after I solve for x instead of having to solve for x and then solve for y. Whereas if I solve for y and it got a -6, I'd have to plug it back in to figure out what my x value is. So I'm just going to solve for x in this case. To do that, I'm going to want to eliminate my y values, y terms. So I'm going to use elimination. I'm just going to write the first equation up here. Now the second equation, I'm going to want to multiply that by -2, because what's going to happen is that I'm going to get a -4y, and I'll get a +2x, and then I have -19 times 2, that's going to be positive. That's going to be positive 2038. Okay, so now if I add these two equations together, I see that my y's cancel out. I've got 5x equals, well, that's going to be a +15. Okay, divide by 5, I get x is 3. Okay, there's only one solution where x equals 3, so that would be B. Okay, for this problem, we're going to be using a little function notation. It tells us that for the function g defined above, a is a constant and g of 4 is 8. Well, if g of 4 is 8, that means that if we put 4 into our function for x, we should get out an 8. G of 4 equals 8. Well, that's going to be 16a plus 24. I'm going to subtract 24 from both sides, and I'll get that -16 equals 16a. Okay, I divide both sides by 16, and I get -1 equals a. All right, that's great. So now we want to know, that's not our solution, that's not our answer, but we want to plug that into the equation for g of -4. Well, that means we have -1 is a, and we'll have -4 squared plus 24. Okay, well that's going to be -1 times -4 squared, which is 16, plus 24. Okay, it's -16 plus 24. Well, that's going to be positive. It's going to be +8. So A is our answer. Okay, number 11. We have what looks like a system of equations. Says in the equations above, B and C represent the price per pound in dollars of beef and chicken respectively, X weeks after July 1st during last summer. What is the price per pound of beef when it was equal to the price per pound of chicken? Okay, so that's strictly a system of equations, right? We've got one linear equation, we got another linear equation, and we want to know the point at which they intersect. All right, so what we could do here is to understand that what we're looking for is we want to know when beef and chicken were the same price. Okay, well, if B and C are the price of beef and chicken, then we want to know when B equals C. Okay, well, B is $2.35 plus 25 cents X, and C is $1.75 plus 40 cents X. Alright, so now we're just going to solve this system of equations. I'm going to start by subtracting $1.75, subtracting $1.75. These cancel out. On the right, I'm going to have $1.75 or sorry, 40 cents. On the left, I'm going to have 25 cents x. And what's this going to be? This is going to be 5 minus 5 is 0. 13 minus 7 is 6. And then that'll be 0. So we've got 60 cents plus 25 cents x equals 40 cents x. I'm going to subtract my this 25 cents x here. That's going to cancel out with that. I get 6/10 equals, well, that's going to be 15/100. Now I can just divide by 15/100, and I get, well, that's going to go in, 15 goes into 60 4 times. So that's x equals 4. So remember that x was weeks after July 1st. X is not the price of chicken and beef. So we need to plug that back into one of our original equations. I'm going to pick the first one. So I'm going to say beef equals $2.35 plus $1.25 times 4. Okay, well, B equals 235 plus 25/100 times 4. That's just 1. So B, the price of beef was $3.35 when the price of beef was equal to the price of chicken. So that's $3.35. Okay, number 12. Line in the xy plane passes through the origin, and let's get this, passes through the origin, and has a slope of 1/7, and we want to figure out what other point is on the line. Well, 0.7 is going to be up here. That's not going to be on the line. 1/7. Well, gee, this is saying the slope is 1/7. Well, that's saying as y changes 1, x changes 7. Now, the graph that I drew probably isn't to, well, definitely is not to scale. But what we see is that if we go over 7, we're going to go up 1 unit. This will be 1. Again, not to scale, right? So if we go over 7 and up 1, that means the point 7, 1 should be on the graph. And clearly, if 7, 1 is on the graph, 1/7 is not on the graph, and 7/7 is not on the graph. So it looks like D is our only solution in this case. And in fact, if we go over another 7, right, another 7 over, we'll get to 14, and then we go up another 1, we'll be at 2. So 14, 2 is our solution. Alrighty, number 13. If x is greater than 3, which of the following is equivalent to this compound fraction? Alright, well, it looks like we're going to have to simplify this fraction. To simplify the fraction, we need to make one fraction in the denominator and one in the numerator. Well, the numerator is already, there's just a 1, so that's done. That's done. So the bottom, to add these fractions, we're going to need common denominators. So on the left fraction, I'm going to multiply that by x plus 3 on top and bottom. And the other one, I'm going to multiply by x plus 2 on top and on top and bottom. Alright, so if I combine these, I'm going to get 1 over, well, x plus 3 plus x plus 2, that's going to be 2x plus 5, and the denominator is just x plus 3, x plus 2. Alright, so we also know that dividing by a fraction is multiplying by its reciprocal, so we can multiply, this is the same as 1 times x plus 3, x plus 2, over 2x plus 5. Alright, multiply that out, we'll get some kind of trinomial in the numerator. In fact, I'll just expand that. That's x squared. That'll be plus 5x, and then plus 6 over 2x plus 5. But as it turns out, we didn't actually have to expand it because the only solution on the left here that had 2x plus 5 in the denominator was b. Okay, so we got 3x minus y equals 12. What is the value of 8 to the x over 2 to the y? What does that equal? Okay, well, we're going to have to use some of our properties of powers. Okay, this expression over here, this 8 to the x over 2 to the y, it would really be handy if I could write both the numerator and denominator in with the same base, which I can. I already see that 8 is really 2 to the third, so that's 2 to the third to the x, and y, well, the denominator is just 2y. Okay, well, I'm going to use my property of raising a power to a power. I'm going to multiply the exponents. Okay, so now that I've got a common base in the numerator and denominator, I'm going to use my quotient rule for powers. If I'm dividing by a power with the same base, I subtract the exponents. So I get 2 to the 3x minus y. Well, we already know that 3x minus y equals 12, so this is 2 to the 12th. That's A is our solution. Okay, we've got this equation here, and for all values of x, and we want to, it's true for all values of x, and we know that a plus b equals 8. What are the two possible values of c? Alright, so let's dive in. Okay, if I expand this business going on over here on the left, I think that would help. Let's see. Let's get this. If I have ax plus 2 times bx plus 7, and I expand that, I'll get ax plus bx, which is ab x squared, and then I'll get plus 7ax, then I'll get plus 2bx, and then finally I'll get plus 14. Okay, so I'm just gonna, what I see here is that if I could figure out what the coefficients are, I could just equate the coefficients, right? I know that AB, well, that's on the squared term. 15 is the squared term on the second expression here. So I know that AB must equal 15. Well, what's the coefficient on x? Well, let's see. I'm gonna pull out. We've got 7a plus 2b times x. I just factored out that x out of those two terms, plus 14. Okay, well, that's c. The coefficient on x is c. So I know c equals 7a plus 2b. Okay, well, We know that a plus b equals 8. We also know that a plus b a times b is 15. Well, gee, so a or b, one of the two, has to equal 3 or 5. 3 or 5. Okay. So then we want to know what c equals. Well, c equals this expression right here. And either b is 3 or it's 5, in which case a would be also 3 or 5. So I'm going to do two cases. We got c. I'm going to do the case where b is 3 and c is 5, or sorry, a is 5. Well, we're going to get 35 plus 6. That's going to be 41. Well, the other case could be where a is 3 and b is 5, in which case we'll have 21 plus 10. That's going to be 31. So our two possible answers are 41 and 31, and that looks like D. Alright, for 16, looks like we are trying to solve a quadratic. And it says that we're only looking for t values greater than 0, or positive t values. Well, you should recognize that this is a difference of squares, and difference of squares are going to this is going to factor as t minus 2, square root of the first times square root of the second, or sorry, square root of the first minus square root of the second, times square root of the first plus square root of the second. Okay? Alright, well, we can use the zero product property at this point, and this tells us that t is going to equal 2, or t is going to equal negative 2. Well, we already know that the restriction is that t is greater than 0, so t must equal 2. Okay, number 17. A summer camp counselor wants to find a length x. That's this length right here. In feet across a lake as represented in the sketch above. The length represented by AV, EB, BD, and CD on the sketch were determined to be 1,800 feet. And I'm just going to write those in as I'm reading them. So it says that AB is 1,800 feet. It says that EB is going to be 1,400 feet. And it says that BD is 700 feet. And it says that CD is 800 feet. Okay. Alright, well, the key to this problem, I think, is this little notation here and here. That's a congruency marker. That means that those two angles are congruent. And we also know that these angles are vertical angles. Those are going to be congruent. Therefore, two triangles share two angles are congruent. Therefore, the third must also be congruent, and the triangles must be similar. If the two triangles are similar, then the side lengths are going to be proportional. So we just have to figure out what side corresponds to what side. So it looks like this 800 corresponds to x, and we need to find the value of x. Okay, good. And it looks like 700 on the small triangle is going to correspond to 1,400. Okay. Alright, well, before I get started, it'd be good to simplify my fraction on the right a little bit. So we've got 7/14. Alright, now if I cross multiply both sides by 14, multiply both sides by x, I'm going to get 7x on the right, and on the left I'm going to get, what's that going to be? Let's see, 14 times 8, it's 2, 3, it's 11, and 2 zeros. Okay, so now I need to divide by 7. I get x equals, well, okay, I'm going to do a little scratch work down here. 7 goes into 1, 1, 2, 0, 0. Well, it goes once with a remainder of 4. And that goes 6 times, evenly, 0, 0. So, looks like x is going to be 1,600 feet. Okay, 18. It looks like we have another system of equations. It's asking us to solve for the value of x. Okay, so if I'm solving for the value of x, I want to end up with an equation just in terms of x. I want to eliminate the y variable. Okay, so to do that, I could either use elimination or substitution. I'm just going to use elimination. I'm going to multiply the top equation by -2. And what I'll end up with is -2x minus 2y equals 18. And my second equation is x plus 2y equals -25. Well, now I can add these two equations together, and I see that my y's will eliminate. And I'll just end up with -x equals -7. So x equals 7. Alright, number 19. In a right triangle, one angle measures x. Okay, so let's draw this. Got a right triangle, let's call this x. Alright, and it says that sine of x is 4/5. Well, sine of an angle equals opposite over hypotenuse. So opposite is going to be that side, that's going to be 4, and the hypotenuse must be 5. Okay, well, if they want to know what cosine of 90 minus x is, well, 90 minus x, well, this angle's 90, this angle's x, what's this angle up here? Okay, if all the sides add up, or sorry, all the angles add up to 180 degrees in a right triangle, or in a triangle, then this angle up here must be 180 minus 90 minus x. Well, that's just going to be 90 minus x. Okay, so we're taking the cosine of this angle up here. Alright, well, cosine of an angle equals adjacent over hypotenuse. Well, what is the adjacent? The adjacent to this angle is 4. So cosine of 90 minus x is going to be 4 over the hypotenuse, which is 5. So 4/5. Alright, number 20. We've got a equals 5 times root 2, and 2a equals root 2 times x. What's the value of x? Okay, so we already know what a equals, so let's plug that in. We've got 2 times 5 root 2 equals root 2x. Okay, alright, well, that's going to be 10 root 2 equals root 2x. Okay, so we can just square both sides at this point. We'll get 100 times 2 equals 2x, and then divide both sides by 2. We'll get 100 equals x. Section 4, this is going to be the calculator section. So let's get started. All of the formulas are provided again, so you'll have that for reference. All right, first problem on section 4. This problem is asking for, it says this is a graph of John's speeds in his running program. The graph shows his target heart rate at different times during his workout. Which interval is the target heart rate strictly increasing then strictly decreasing? Well, if we just look at the graph before we go down to the possible answers, I can see that we got increasing and then constant and then decreasing. Well, that's not going to be it. Right here it's increasing, and then immediately after that it's decreasing. Okay. This next piece is increasing and then constant. That's not it. This is increasing and then constant and then decreasing. Well, it's not going to be it either. So looks like we're looking at this interval of 40 to 60, and that is one of our possible solutions. Okay, so next we have y equals x or kx, where k is a constant, and y equals 24 when x equals 6. What's the value of y when x equals 5? So this is a common problem. We need to find the value of k, and then we can use the equation to figure out what y equals when x equals 5. So we're going to start by writing that we know that y equals 24. This is y equals kx when x equals 6. So if we divide both sides by 6, we see that k equals 4. And then we need to plug our x equals 5 back into the equation with the k equal 4. Okay, so we get 20. Next problem, number 3. Looks like we've got a couple parallel lines. Let's see if they are parallel. In the figure above, the lines L and M are parallel, what do you know? And S and T are parallel. So we have some transversals. If the measure of angle 1 is 35, what is the measure of angle 2? Okay, so this is 35 degrees here. 35. Well, I know that this is a corresponding angle, so that's also 35. And then I know that this is a vertical angle, so I know that's 35. And then here, these two angles are same side interior, and that means they're going to be supplementary. Therefore, 180 equals 35 plus angle 2. So that's going to be 145 is going to be the measure of angle 2. Okay, we got our next problem, problem number 4. If the value of 16 plus 4x is 10 more than 14, what is the value of 8x? Well, let's figure out what x is. 16 plus 4x is 10 more than 14. Well, that's going to be 14 plus 10. Okay. That's going to be 16 plus 4x equals 24. We're going to subtract 16 from both sides, and we're going to see that x equals 2. Well, we want to know what 8x is. Well, that's going to be 8 times 2 is 16. Okay, got some scatter plots. Which of the following graphs best shows a strong negative association between D and T? Well, a positive association would have a positive slope. Negative would have a negative slope. Line of best fit. And the tighter the values are together, closer they are to a single line, is the stronger the correlation. So we're looking for a strong negative correlation. So it looks like we're going to be D. Okay, for number 6, looks like, let's just read through this. We got a hospital stores one type of medicine in 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in one 2 decagram container? Well, there are 2 decagrams, okay, and there are 10 grams in each decagram. So we have 2 decagrams, and we have 10 grams per container. So that means we're going to have 20 grams total. All right, well, if we have 20 grams, we see that there are 1,000 milligrams in every gram. So 20 grams times 1,000 milligrams, well, that's going to be 20,000 milligrams. Okay. Well, if we have 20,000 milligrams and each dose is 1 milligram, then we must have 20,000 doses. Okay, here we go, number 7. We see this is a graph of solar panel installations in 5 cities. The number of rooftops with solar panel installations in 5 cities is shown in the graph above. If the total number of installations is 27,500, what is an approximate label for the vertical axis of the graph? All right, well, if the total is 27,500, well, let's see how many units they have on this graph. Meaning, this first column here is going to be 9 units, so that's 9. Then we have 5 units on the vertical scale. We have 6 units on the vertical scale. We have 4 units on the vertical scale. And we have what looks like 3.5 on the vertical scale. So if we add that all up, we're going to get, so 9 and 5 is 14. 9 and 5 is 14. 14 and 6 is 20. 20 and 4 is 24. 24 and 3.5 is 27.5. So there are 27.5 units accounted for on this graph, and we see that there are 27,500 solar panel installations. So that means that each one of the units on the graph must equal 1,000, right? Because 27.5 units times 1,000 per unit, well, that's going to equal, let's get a pen here, 27, and then we're moving the decimal 3 spaces to the right, so it's 1, 2, 3. That's going to equal 27,500. Therefore, it looks like our answer is going to be C. Okay, problem number 8. It says, for what values of n is n minus 1 plus 1 equal to 0? Well, we're solving an absolute value, so we need to isolate the absolute value expression. Subtract 1 from both sides. I'm going to get the absolute value of n minus 1 is equal to -1. Well, we should know that the absolute value of the absolute value is always going to be greater than 0. When we look at this graph of y equals absolute value of x, we never get a negative output from our absolute value function. And in fact, this function is just moved to the right 1 unit. Okay, so we're not going to have any such value, d. Okay, so here we are at problems 9 and 10. We've got a linear equation here, and it looks like it's relating the speed of sound wave in air depends on the air temperature. The formula above shows the relationship between A, the speed of sound wave, and in feet per second, and T, the air temperature in degrees Fahrenheit. So I'm just going to highlight those. We've got A is the speed of the sound wave, and T is the temperature Fahrenheit. It says, which of the following expressions expresses the air temperature in terms of the speed of a sound wave? Okay, well, these kind of questions are just asking you to solve a literal equation. All we need to do is solve this equation for T, right? As we can see, T is solved for in each of these answers, each of these solutions, and that's what it's asking for. It's asking for the temperature in terms of the speed of the sound wave. So we're just going to rearrange these terms until we get our T all by itself, our temperature. Okay, well, we've got two terms. I'm going to subtract 1052 from both sides. A minus 1052 equals 1.08 T. Okay, you probably see already. We're going to divide both by 1.08, and we get A minus 1052 over 1.08 equals T. And we can see that that is going to be our first solution here, A. Okay, number 10. This is referring to the same equation. And number 10 is asking us at which of the following air temperatures will the speed of sound wave be closest to 1,000 feet per second. Okay, so if we know the speed of the sound wave is 1,000 feet per second, then we can set A equal to 1,000. We're just going to plug that into our equation. 1,000 feet per second equals 1,052 plus 1 800 T. Subtract 1,052 from both sides. We're going to get negative 52 equals 1.08 T. Okay. Divide by 1.08. Divide by 1.08. And we see that T is going to equal, so I'm going to have to do a little calculation here. Let's see, 52 divided by 1.08. Okay, so I'm going to get 48.14. And it keeps going, but, and it's asking, negative, it's asking which of the following air temperatures are closest. Well, that's going to be B. Yeah, we're going to have to round, but we'll round down for this one. Okay, so we have an inequality for number 11. It's asking which of the following numbers is not a solution to the inequality. So we just need to solve the inequality. And once we solve it, we'll check the values and figure out which one does not satisfy the inequality. Okay, so I'm going to subtract 3x from both sides. I'm subtracting 3x because that's going to give me a positive coefficient on the x term. and I like having positive coefficients, so it's just going to be 1x, add 3, negative 2 is greater than or equal to x. Alright, so is negative 1 greater, or sorry, I guess we have to think about this, right? Because this can rewrite it as x is less than or equal to negative 2. Okay, is negative 1 less than or equal to negative 2? Well, no, that's not less than or equal to negative 2. Sure seems like that's going to be our solution. Let's check the other ones. Negative 2? Yeah, negative 2 is equal to negative 2. Negative 3 is less, and negative 5 is also less. So A would be our solution. Okay, number 12. Based on the histogram above, of the following, which is closest to the average number of seeds per apple? Okay, well, if we want to know average, we're going to have to add up the total number of seeds for all apples and divide by how many apples we're talking about. So if we see that the number of seeds, the number of seeds in the apples is on the horizontal axis and the number of apples is on the vertical axis, well, then we can make an expression. We know that there are going to be two apples with 3 seeds. Okay, so that's going to be 2 times 3. And then we see that there are 4 apples with 5 seeds. Okay, so then it's 4 apples with 5 seeds. And then there's 1 apple with 6 seeds. Okay, so that's 1 apple with 6 seeds. And then there are, let's see, again there are 2 apples with 7 seeds. Okay. Oops. Gonna have to squeeze this in there. It's okay. And finally, we see that there are 3 apples with 9 seeds. So plus 3 apples with 9 seeds. What's that going to equal? It's going to be 2 times 3 is 6. 4 times 5 is 20. 1 times 6 is 6. 2 times 7 is 14. And 3 times 9 is 27. Okay? So I'm just going to add those up. We're going to get... I'm just going to do it on the calculator here real quick. 2 plus 20 plus 6 plus 14 plus 27. Okay, so that's going to total 73. Now to find the average or arithmetic mean, we need to divide by the number of apples that there are. Well, we know that there are 12 apples. It told us that, right? 12 apples. So we're going to divide 72 by 12. Okay, and we want to know what's closest to this value. We're just going to do 73 divided by 12 on my calculator here. I'm going to get 6.083 repeating, and that's going to be closest to C, 6. Okay, so looks like what we have here is a two-way table. It's students enrolled in some math classes and split up by gender. Okay, let's go through this. A group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data were broken down as shown in the table above. Which of the following categories accounts for approximately 19% of the survey respondents? Well, okay, let's see. How many survey respondents are there? Well, there are 150 female, there are 160 male, and there are 310 total respondents. So we should probably figure out what 19% of 310 is. Okay, well, if we do whole times the percent times percent is going to equal the part. Okay, so the whole is 310 and the percent is 19%, but we need to write that as a decimal. So we need to divide 19 by 100. 19 divided by 100 is going to be 0.19. Okay, I'm going to go over to my calculator here. And I'm just going to type in 310 times 0.19. Oops, 310 times 1900ths. Well, that's 58.9. Okay, so which one of these is going to match 58.9 or get close to that? Females taking geometry. Let's see how many females are taking geometry. Females taking geometry, 53. Females taking algebra 2, 62. Males taking geometry, 59. Oh, well, gee, that's really close. And males taking algebra 1, 42, or 44, sorry. Okay, well, clearly it's going to be males taking geometry at 59. Okay, number 14. We're looking at the table here. It shows the length of fish in inches. And the table above lists the lengths to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. Of the mean, median, and range of the values listed, which will change the most if the 24-inch measurement is removed from the data? Okay, so let's first look at the range, because that's easiest to calculate at this point. The range is going to be 24 minus 8, 16. Okay. Okay, well, if that's pretty large. Now, if we remove that outlier of 24, the new range would be 16 minus 8, or 8. So the range would change by 8. It would decrease by 8. Okay, so now let's take a look at the median. Well, the median value is just going to be in the middle. So it's got to be somewhere around 12. Okay. Now, if we eliminate, or we take out 24, well, then the median value, it's going to go down, right? It might go down. Oops. Let's take the highlighter. It might go down to 12. Ooh. Or maybe it's going to go down to the next one, which is also 12. So the median is not going to change that much at all. Okay. Next, let's talk about the mean. So the mean, let's see the highlighter here. Okay. So the mean, well, it's clear this data set is clearly weighted towards the bottom end. It's weighted away from 24. And let's just say that it's the mean. I'm going to make an estimate. And if I made an estimate, I might say that the mean is at 13. Okay. Now, if we take away 24, the mean is going to be between 8 and 16. So the new mean has to be in the range of 8 to 16, so it's going to go down. Therefore, it has to be in the range of 8 to 12 or 8 to 13. It's not going to go down by that much. Therefore, the mean is really only going to change by approximately, couldn't change by more than approximately 4, I would say, just an estimate. So I think the mean couldn't possibly be correct. All right, well, we already know that 8, the range is changing by 8. So I'm going to say that 8 is the largest change. Okay, for number 15 and 16, we've got a graph here that's showing us the total cost of renting a boat by the hour. It's graphed on an HC axis, hours versus cost axis. And it says the graph above displays the total cost C in dollars of renting a boat for H hours. 15. So what does the C-intercept, the Y-intercept, right, essentially, the C-intercept, where the graph touches the C-axis, what does that represent? Well, it's going to represent, on the C-axis, that's total cost, right? This represents if you are renting the boat for 0 hours, what the total cost is. Total cost for 0 hours appears to be $5. Well, that is going to be the initial cost of renting the boat. It's not the number of boats. It's not the number of boats rented, right? The total number of hours the boat's rented, well, that doesn't. It's not even hours. It's dollars. And the increase in cost. Well, the increase in cost for each additional hour is the slope of the line, which can be calculated by the rise over the run. But that's also not what this is showing us. That's the y-intercept, or the initial value. Okay, still talking about the boats. 16 here is asking which of the following represents the relationship between H, hours, and C, cost. Well, we should recognize that this is going to be a linear equation. Y equals mx plus b, where b is the y-intercept, and in this case c-intercept, and m is the slope. Okay, well, the y-intercept for this graph is 5. Okay, so we should have a constant in our equation, and we don't have a constant in either of these, so those can't be. Well, the only difference here is going to be the m value, the slope between these two. Well, what is the slope? Slope is change in y over the change in x. So let's figure out what the change in y is. Let's pick between 2 points, maybe here and here. Well, what is that change from there to there? That's going to be from 8 to 11. Change in y is 3. And from 1 to 2, well, that's a change of 1. Okay? Don't be confused. A lot of students might go in the count, oh, that's 1, 2, 3, 4. And they would pick B for a solution. But we are better than that. We know that the slope is simply 3. Okay, so we got number 17. The complete graph of the function f is shown in the xy plane above. For what value of x is the value of f of x at its minimum? Well, f of x equals y. It's handy they even show you that right there. So where is y at a minimum? Y is at a minimum right here. Okay? And we're saying, it's asking what value of x is the function at a minimum. Well, that's -1, -2, -3. So it's going to have a minimum at x equals -3. Okay, for 18, we have a system of inequalities. In the xy plane, if 0, 0 is a solution to the system of inequalities above, which of the following relationships between a and b must be true? Okay, well, this is going to require a sketch. Now, this is not to scale, obviously, because we don't have values here, but we do know some things. We know that we are going to be, for the first equation, we know that we are going to be shading below the line because y is less than the line. We also know that the line has a -1 slope. Well, if 0, 0 is a solution, that has to be part of our shaded region. So this must have a negative slope above 0, 0. Okay? Because if we're shading below the line, 0, 0 has to be in that shaded region. Okay, also, the second one, that is, we're shading above the line. And if we shade above the line, well, the line must have a y-intercept below 0, 0, because we have a positive slope here. +1 slope. So it's going to be something like that. And we shade above the line. Okay? So what we see here is that this 0, 0 is in the double shaded region. It's a solution to this hypothetical system of equations that I've graphed. Well, we also know that the y-intercept for the first graph going down with the negative slope is a, and the y-intercept for the second graph is b. Okay, well, the first one says that a is greater than b. Well, it sure looks like a has to be greater than b. Let's go ahead and read the rest of them. B is greater than a? No, I don't think that can be possible. It says that a is greater than, the absolute value of a is greater than the absolute value of b. Well, that's not necessarily true. I mean, you could imagine a situation where the graph of b, was going down something like this, yeah? In which case, the absolute value of this would be greater than the absolute value of a. Okay, so that's not it. And then a equals -b. Well, that doesn't have to be true at all. So, a. All right, here we go, number 19. A food truck sells salads for $6.50 each and drinks for $2 each. The food truck's revenue from selling a total of 209 salads and drinks in one day is $836.50. How many salads were sold that day? Well, we need to write a system of equations for this. The first equation I'm going to write is the total number of salads and drinks. Well, that must equal, I'm going to use X for salads, and I'm going to use Y for drinks. Okay. Doesn't matter. I just don't like using an S generally in my equations. I have kind of sloppy handwriting, so sometimes my S's look like 5s. Okay, so my next equation, well, it says that we had a total revenue that day of $836.50 from selling salads and drinks. Well, the revenue from selling salads must be the number of salads times the cost of the salad, which is $6.50. And the revenue from selling drinks must be the number of drinks times the cost of a drink. So I have 6 and 5/10 x plus 2 times y should equal $836.50. Okay, well, to solve this, it says solve how many salads were sold. If I use elimination, or if I use substitution to solve this, either way, I should be thinking about eliminating the drinks. Yeah. So, well, I think I'm just going to add the two equations together and eliminate the drinks, which are y. Now, to do that, before I add them together, I need to multiply this by -2 so that I get additive inverses with my +2 here. Okay. So if I multiply this through by -2, I'm going to get negative 418 equals -2x minus 2y. Now, if I add these together, these two equations together, I see that my y's cancel out. I'm going to be left with 4.5x, and I'm going to bring up my calculator, and I am going to subtract 418 from 836.5. 418, and I am going to end up with 418.5. Okay, we're going to divide both sides by 4.5. Let's cancel out. We get, pull up my calculator again, divide it by 4.5, get 93. So 93 salads were sold that day. 93 salads. Okay, number 20. Alma bought a laptop computer at a store that gave a 20% discount off its original price. The total amount she paid to the cashier was P dollars, including an 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? Well, if she paid P, the original price, P will equal the original price after the discount and then after the tax. So the original price, let's say that is X. Okay. Well, we know that she got a 20% discount. So if we want a 20% discount on something, that means we're not paying 100%, we're paying 80%. So we're going to multiply by 80%, which is 8/10. Okay? So that's the price after the discount. Now, there's also going to be a tax. Well, the tax is 8%. So we're not paying 100%, we're paying 108%. So 108% as a decimal is 1.08. Okay, so now we have the purchase price, P, based on X, the original price. And then we want the original price in terms of the sale price. So we just need to isolate the X variable. I'm going to divide both sides by 1.08. We're going to get X times 0.8. Okay, well, then we're going to multiply both sides, or sorry, divide both sides by 0.8, and we're going to get the original price is equal to P divided by 1.08 times 0.8. Okay, here we go. 21. Dreams recalled during 1 week. Group X and Group Y. It's a two-way table. The data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes, and Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random from those who recalled at least one dream, what is the probability that the person belonged to Group Y? Well, the people who recalled at least one dream, well, that's going to be that group, and that's going to be that group. So how many people are in these two groups? Well, we need to look at the totals for these two. So we've got 129 or 125 plus 39, 4, 1, 6, 6, and 1. 164 are in the group of people who observed more than at least one dream. Okay, so out of that group, how many are going to be in group Y? Oops. Let's get this better here. Belong to Group Y. Well, Group Y, it looks like there are 11 and 68, so there are going to be 79 in Group Y. So 79 out of 164. 79 out of 164. Okay, 22. We've got a table here that's showing us the annual budgets for different programs in Kansas, 2007 to 2010. And number 22 is asking which of the following best approximates the average rate of change in the annual budget from agriculture, natural resources in Kansas from 2008 to 2010. Okay, so we need to look and see what the budget was in 2008 for agriculture or natural resources. Well, that's going to be 358,708. And then we look for what the budget was in 2010. Okay, and remember that average rate of change is just the change in your output, which is or your change in your dependent, which is the cash. So we've got 488,106 minus 358,708 over the change in our input, which is years. Well, it's going to be 2010 minus 2008. Okay, so I'm going to pull up my calculator here, and I've got 488,106 minus 358,708, and that equals 29398 over 2010 minus 2008. That's 2. Okay, so I'm just going to divide that by 2, and I get 64,699, and it looks like we're closest to B. Okay, number 23. Still working with the same table here. This time of the following which program's ratio of its 2007 budget to its 2010 budget is closest to the human resources program ratio of its 2007 budget to its 2010 budget. Okay, so let's first look at the human resources program's ratio from 2007 to 2010. Well, the human resources budget in 2007 was the $4,051,000, and the budget in 2010 was $5,921,000. Okay, and we want to figure out which other most closely matches that. Well, it looks like we're going from just to approximate. We're going from 4 to approximately 6. Okay, so that's essentially a 1 to 1.5, 1 to 1.5 ratio. Okay, and if we look at agriculture, is it a 1.5 ratio to go from 370 to 480? Well, not quite. I mean, it's an increase of 100, or a little bit over 100,000, but 100,000 is not half of 370,000. So I don't think that's it. Education went from 2,160,000 to 300,000. So that's pretty close. That's about a 2 to 3. It's approximately 2 to 3, which is a 1 to 1.5. So I'm thinking education is probably going to be our answer. Let's go on to check out the other ones. C, highway transportation. Highway transportation, let's see. We got highway transportation went from about 1.5 to 1.7 million. Well, that's definitely not what we're looking for. And public safety went from 260,000 to 460,000. So that's an increase. Gee, that's almost double. So I'm gonna go with B. Education had a ratio of 1 to 1.5. Okay, so for this one, we have which of the following is an equation of a circle in the xy plane with a center at 0, 4 and a radius with endpoints with an endpoint at 4/3 and 4/3 5. Okay. All right. Well, if we want to know what the center is, we need to think about the equation of a circle. Equation of a circle is going to be x minus h squared plus y minus k squared equals radius squared. Okay, we know the center HK is 0, 4, so we can plug that in. We've got, well, it'd just be x squared because h is 0, and then we've got y is 4, so it'll be minus 4 squared equals the radius squared. So right away we can rule out B and D. So now we just need to figure out the radius. Well, the radius is going to be the distance from the center to the endpoint. Okay, and we're going to use the distance formula. Make a note off to the side here. We're going to use the distance formula, which is distance is equal to the square root of, x minus x1, or x1 minus x2, either way. So we're going to go, I'm going to go from 4.3 minus 0, 4.3 minus 0, well, that's just 4.3 squared, plus, we have 5 minus 4 squared. We're taking the square root of all of that. Well, that's going to be 16 over 9 plus 1. 1 squared. Now 1 squared is just 1, but instead of writing it as 1, I'm going to write it as 9 over 9. Okay. Then I've got the square root of, well, add the numerators. So I get 25. Denominator stays the same, 25 ninths. Okay, well then that's going to equal d, or in this case the radius is going to equal 5/3. Okay. Oh, well, I didn't even need to take the square root, right? I want the radius squared. Well, radius squared in this case is going to be 25 ninths. Okay, and that means that our answer is going to be A. Okay, problem number 25. We've got a quadratic here. The equation above expresses the approximate height in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? Okay, so this has a negative leading coefficient, so it's going to look something like this. Okay, this parabola, and we essentially want to find this point. All right, this point is going to be when it hits the ground, when the elevation or the height is 0. Okay, well, we want to know where the height is 0. This is going to give us some. It's going to give us some t with a 0 for height. Okay, well, if height is 0, I'm just going to plug that in for h. Okay. All right. Well, a couple ways to go about this. Probably the easiest way is to factor. I'm going to factor out a t. So if I factor out a t, I get negative 4.9 t plus 25 times t equals 0. Well, if I multiply two numbers or two values together and I get 0, then one of two things must be the case. Either the first factor is 0, or the second factor has to equal 0. And t equals 0, well, that's not when it hit the ground, that's when it got initially launched. So I'm going to solve this second equation here. I'm going to subtract 25 from both sides, and I'm just going to divide both sides by negative 4.9. Well, if I divided by 5, that would be 5 even, so I'm pretty sure it's going to be d here, 5.0, but I'm going to go to my calculator and just divide this right away. I get 25 divided by 4.9 is 5.102 on and on. So 5 seconds. Okay, problem number 26. Katrina is a botanist studying the production of pears by two types of pear trees. She noticed that type A trees produce 20% more pears than type B trees. Based on Katrina's observation, if type A tree produces 144 pairs, how many pairs did type B produce? Well, we know that it says that she knows that type A produced 20% more pairs. So A equals B times 1.2, because this is 120%. When we convert 120% into a decimal, it becomes 1.2. So A, the production of A should be 1.2 times B. And it says that if A produced 100, nope, don't want that, produced 144 pairs, how many did B produce? Okay, well, we just plug in our values. 144 equals B times 1.2. You can divide both sides by 1.2, and we're going to get, go to my calculator here, 144 divided by 1.2, 120 should be B. Okay, 27. A square field measures 10 meters by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is square and has side lengths of 1 meter, and no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. The results are shown in the table. Okay, so we have regions A, B, C, D, and E, F, G, H, I, and J. Which of the following is a reasonable approximation for the number of earthworms to a depth of 5 centimeters beneath the ground surface for the entire field? Well, if we take an average of the number of earthworms in all of these regions, and each region is 1 meter square, then we can multiply that by the total area in meters for the whole field. Okay, so we're going to add up these and these guys, okay, and then we're going to divide by 10 because there are 10 separate regions. So I'm going to pull up my calculator here. It's going to be 107 plus 147 plus 146 plus 135 plus 149 plus 141 plus 150 plus 154 plus 176 plus 166. Okay, so total number of earthworms that they selected, or they found in their regions, was 1,471. We're going to divide that by 10, and we get 147.1 per region. Okay, well, the whole field is 10 by 10. A 10 by 10 field, well, that's going to be 100 square meters, so we need to multiply this by 100. Okay, if we multiply by 100, we're going to move the decimal to the right 2 spaces, and it looks like it's going to be 14,700. So C would be our approximation for the total number of earthworms across the field. Okay, so 28. If a system of inequalities, y is greater than or equal to 2x plus 1 and y is greater than 1/2 x minus 1, is graphed in the xy plane above, which quadrant contains no solutions to the system? All right, well, let's just graph it. We've got our first one here. Oops, let's highlight that instead. Yep. So 2x plus 1, and y is greater than or equal to. So that means it's going to be a solid line. And our y-intercept is 1 with a slope of 2. So I don't know, maybe something like that. And we know we're going to be shading above. Okay, So for our next equation, we've got y is greater than 1/2 x minus 1. Well, that's going to be dotted because it's strictly greater than, and it has a positive slope of 1/2, and it has an intercept of -1. So we are going to have something like this, maybe very shallow. Okay, and we are shading a, oops, that should have been dotted. So let's try that again. And we are shading above. Okay, so it looks like we've got some solutions in 2, clearly, a lot of solutions. We've got some solutions in 1, right? So some solutions in this region. And it looks like we've got some solutions in 3 in that region. But we don't have any solutions in quadrant 4. So C would be our answer. Okay, number 29. For a polynomial p of x, the value of p of 3 is -2. I'm just going to write that out. Value of p of 3 equals -2. Okay, which of the following must be true about p of x? Okay, so the value of p of 3 is -2. That means that there's a point 3, -2 on the graph. Okay, so when I put in a 3, I get out a -2. Alright, so let's look at these. So it says x minus 5 is a factor of p of x. Well, I don't know if we can determine that. B, x minus 2 is a factor of the graph. Again, I don't think we can really figure out what is a factor of this graph because we don't know what the x-intercept is. If we knew what the x-intercept was, we could tell something about a factor of the graph, but at this point I don't think so. X plus 2 is a factor of p of x. Can't tell that. And D, the remainder when p of x is divided by x minus 3 is -2. Well, yes, that's the remainder theorem. If we divide a polynomial by one of the roots, or one of the factors of the polynomial, our remainder is 0. Okay, and that's going to give us a x-intercept. If we divide a polynomial by a factor that gives us a remainder, we're dividing by something that is not in fact a factor, then that remainder equals the value of the function at that x input. So that means that if p of x is divided by x minus 3, well, we're going to get some answer plus a remainder, and the remainder is going to be plus a -2 over x minus 3. This right here, this remainder, is the value of the function at 3. It means that p of 3 equals -2. Okay, number 30. Which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of the vertex A can be identified as constants in the equation? Well, the only constants in the equation, let's see. Let's just look, I mean, we can eliminate some of these, right? If we look at the first one, we have 3, -5. Well, this point here is nowhere close to 3, -5, -3, -5, +5. That's way out of the range. can't be that one. The same with the next one. -3 and 5 both have nothing to do with the coordinates of A. It says part C, -2 and -15. Gee, that's close, but not quite. I'd really be focused on this one right here. It looks like we got shifted to the right 1 unit. That's where we get this. And then down 16 units. Okay. Well, there's another way that we can tell. We can take our equation in standard form, and we know that the vertex, the x value of the vertex, is going to be -b over 2a. Well, -b in this case, b equals -2. Well, negative of -2 is +2. Yeah? And 2 times a, well, in our equation, a equals 1. So that's going to be 2 over 2, 1. And the only equation with 1 in it is D. Okay, 31. Wyatt can husk at least 12 dozen ears of corn per hour and at most 18 dozen ears of corn per hour. Based on this information, what is a possible amount of time in hours that it could take Wyatt to husk 72 ears of corn? Okay, well, if he can husk anywhere between 12 and 18 dozen per hour, let's just assume that he husks, in this situation, he husks 12 dozen per hour. Okay, well, 12 dozen per hour, right? And we want to know when that equals 72 dozen. Okay, well, divide both sides by 12. Well, H equals, it's going to be 6, right? 72 divided by 12 is 6. So 6 hours is a possible number of hours it takes him to husk the corn. All right, number 32. The posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. A delivery truck that is carrying X identical boxes, each weighing 14 pounds, will pass over the bridge. If the combined weight of the empty delivery truck and its driver is 4,500 pounds, what is the maximum possible value for X that will keep the combined weight of the truck, driver, and boxes below the bridge's posted weight limit? Okay, so this is an inequality. And we know that the truck without anything in it is going to be 4,500 pounds. But we know we're going to add to that the weight of the cargo, the weight of the boxes. And we know that we have X boxes, and they each weigh 14 pounds. So 14 times X should be the weight of all of the boxes combined. Okay, so what we have here is we have the weight of the truck, driver, and here we have the weight of the boxes. Okay, well, that needs to be less than or equal to 6,000 pounds, because the maximum weight for the bridge weight limit is 6,000 pounds. So we just need to solve for X. I'm going to subtract 4,500 from both sides. I get 14x is less than or equal to, well, 6,000 minus 4,500, that's going to be 1,500. And then I have x is less than or equal to 1,500 divided by 14. I'm going to go to my calculator now. 1,500 divided by 14. It's going to be less than 107. Less than 107.1. Okay, and it says what is the maximum possible value for x that will keep the combined weight of the truck and driver below the bridge's posted weight limit? Well, that means we have to be less than or equal to 107.1. All right, number 33. We got a graph here of the number of portable media players sold worldwide each year from 2006 to 2011. And it looks like it's in units of millions. Okay. All right. According to the graph above, the number of portable media players sold in 2008 is what fraction of the number sold in 2011? All right, so what fraction of 2008, 2011? 2008, it looks like we have, I'll highlight this, 2008, we have 100 million, and in 2011, we have 160 million. Okay, so it's 2008 to 2011, so that's going to be 100 to 160. I'm dropping the millions because it doesn't really matter. We'll drop it anyways. In fact, I'm going to drop the hundreds anyway. So we have 10 to 16, which can be reduced to 5 to 8. So the fraction of sold in 2008 of what's sold in 2011 is 5/8. Okay, 34. A local television station sells time slots for programs in 30-minute intervals. If the station operates 24 hours per day, every day of the week, what is the total number of 30-minute time slots the station can sell for Tuesday and Wednesday? Well, if it's operating 24 hours a day, and we're talking about 2 days of the week, that's going to be 48 hours. That's going to be 48 hours for those 2 days. And each of those hours has two 30-minute blocks. So times 2. 16, 9. It's like 96 30-minute blocks. Okay, number 35. A dairy farmer uses a storage silo that is in the shape of the right circular cylinder above. If the volume of the cylinder is 72 pi cubic yards, what is the diameter of the base of the cylinder in yards? Okay, so the volume, we're talking about volume of a cylinder, so we need to be thinking about the formula for that. Now we could go back to our formula page real quick, and we would see that the volume for a cylinder is going to be pi r squared times the height. Okay, so we're just going to substitute some values in here that we actually know from the diagram and from the text. We know that the volume is 72 pi is the volume, and we know that the height is 8. Okay, so I'm just going to divide both sides by 8 pi. Okay, my pi and my 8 cancel out. Over here my pi's cancel out. I've got 9 equals r squared. Okay, well then 3 equals the radius. Alright, well the radius is not what we're looking for. We're looking for the diameter, and even underlined it. And the diameter is double the radius. So the diameter is going to be 6. Alright, 36. For what value of x is the function h above undefined? Okay, so key for this is undefined. Well, we know that a function is undefined if we are dividing by 0. So we want to know when the denominator to this function equals 0. We want to know when this equals 0. So I'm just going to expand this. When I expand this first squared binomial, I'm going to get x squared. It's going to be x times negative 5, and Negative 5 times x, that's going to be negative 10x. Negative 5 squared. I'm going to distribute this 4. That'll be plus 4x minus 20 plus 4 equals 0. All right, I'm going to come in here and I'm going to combine like terms. I have x squared. That's going to be getting that guy out of the way. And then I've got negative 10x and then positive 4x. So that's going to be negative 6x. And then I've got 20 minus 20. That's going to be 5 plus 4. That's going to give me 9 plus 9 equals 0. Okay, so if we want to solve a quadratic, the easiest way, especially when a equals 1, is we need to look for two numbers that multiply to c and add to b. Okay, well in this situation, two numbers that multiply to 9 and add to negative 6, well, that's going to be negative 3, negative 3. Okay. And then we know that the only thing that can make this equal to 0 is when x equals 3. So the value of x that would make this function undefined is 3. Okay, excellent. So now we're on to problem 36. It says that Jessica opened a bank account that earns 2% interest compounded annually. Her initial deposit was $100, and she uses the expression $100 times x to the t to find the value of the account after t years. What is the value of x in the expression? Well, to figure this out, we need to understand, or we need to know, that the value of the account, typically we say A, is going to be equal to the principal times, well, this is interest, so this is increasing, right? So we don't need to be multiplying by a percent, a 2%. If we multiply by 2% as a decimal, it will get smaller and smaller. We want to multiply by 100%, which is 1, plus that 2%. We've got to turn it into a decimal, so it'd be 2/100ths, okay? And it's going to be raised to the t. So what is the value of x? Well, x is everything inside the parentheses here. Well, that's going to be 1.02. Okay, and we're dealing with the same setup here, except now Jessica's friend Tyshawn found an account that earns 2.5% interest compounded annually. Tyshawn made an initial investment of $100 into the account, this account, at the same time that Jessica made a deposit of $100 into her account. After 10 years, how much more money did Tyshawn's initial deposit have earned than Jessica's initial deposit? Okay, so we need to figure out how much Tyshawn earned and how much Jessica earned. Okay, so let's start with Jessica. Jessica, say J of t, is going to be, it was $100 was the initial investment, and the equation was 1 plus 0.2 raised to the t. Now t, in this case, is 10. So we want 100 times 1.02 raised to the 10. Okay, well now I'm going to pull out my calculator because I'm not good with decimals and powers. So let's see. We've got 100 times 1.02 raised to the 10th. Okay, so Jessica will have earned $121, and it looks like I'm going to round it to the nearest cent. It's 90 cents. Okay, Taishan's function will be $100 initial deposit, and he got a 2.5%, so it's 1.025 raised to the t, and we want to know Taishan, or t of 10. 1.025 raised to the 10th. Okay, I'm just going to plug that in my calculator. 100 times 1.025 raised to the 10th. Well, that's 128, and I'm going to round to the nearest cent, and 1 cent. Okay, so we want to know the difference between these two, so it's going to be 128 and 1 cent minus 121 and 90 cents. Subtract that. That's going to be 1, 1, 6, 0, 0. Well, don't need that. So $6.11.